In this video, we've got a large rational expression that we are asked to simplify. We have 6x to the third times the quantity x squared plus 2, all of that is squared, minus 2x times the quantity x squared plus 2, all of that is raised to the third power. All of that is over x to the fourth. So what is common? Well, first of all, we see that we have x's common here. And you can't just go canceling out if there's things added or subtracted, but this 6x to the third is multiplied by all of this, and this 2x, this x is multiplied by all of this. So what we're going to do is factor out, I'll write this step out, factor out the x, and then what we have left is 6x squared times the quantity x squared plus 2, all of that is squared, minus 2 times the quantity x squared plus 2, all of that is raised to the third power. So all I've done is I've plucked an x from here and here, right? Because that was common in each of these large terms. So x was being multiplied there. Now I can come by and sweep out an x, right? Cancel an x out of the numerator and the denominator, so that becomes x to the third in the denominator. So now all I have left in the numerator is 6x squared and all this other stuff, but I don't have this x right here. So I'm going to factor out this large expression, this x squared plus 2 squared. So I'll be able to pull that whole thing out of this term, and I'll be able to pull out two of those, or the x squared plus 2 squared, out of this one, and I'll still have one left, just like x to the third is the same as x squared times x to the first. And that's all I'm going to do right here when I factor out this whole thing squared. Okay, so that was just a little example. So I am going to do that, and I'll write here 6x squared. Let's back up. Let's first factor out the x squared plus 2. So that will give us x squared plus 2 squared. I'm factoring out that whole thing. What's that being multiplied by? Well, it's being multiplied by a 6x squared, and it's being multiplied by a negative 2, and it's being multiplied by another x squared plus 2. That's why we have it to the third power here. So this is x squared plus 2. You could say to the first power there, like we did with that example. Okay, so we factor this out. We still have that x to the third now in the denominator. Now we can distribute this negative 2, so we'll do that. Distribute the negative 2, and what we have left there is x squared plus 2 quantity squared times 6x minus 2x squared minus 4, because negative 2 times 2 is negative 4. All of that is over x to the third. We'll combine, oh, this was 6x squared. I better be careful there. 6x squared there. We'll combine these two like terms to make it a 4x squared. So we have now x squared plus 2 quantity squared times 4x squared minus 4. All of that is over x to the third. I'm going to continue this right here. All right. Now we can factor out a 4 out of just this, and I'm going to write it in the front. 4 times quantity x squared plus 2, all of that is squared, times, what do we have left here? Well, 4 is being multiplied by x squared, and 4 is being multiplied by a negative 1. 4 times negative 1 gives negative 4. So we're just doing the reverse of distribution. And don't fret about this. I could have written the 4 right here, but I just moved it over there. That's the commutative law of multiplication. Okay, I'm almost out of time here. I've got this x to the third down there. And now we could factor this x squared minus 1 if you wanted. You could write it as 4 times x squared plus 2 quantity squared times x plus 1, x minus 1. It's not necessary, but some answer keys will have it written like that. I hope that helped.